Hello, dear students. In the last lecture, we have studied about the adsorption from solution phase. We have seen some of the examples. Today, we will see the characteristics of adsorption from solution phase. Let us look at the characteristics of adsorption from the solution phase. Number one, the extent of adsorption decreases with increase in temperature. So, when you increase the temperature, the adsorption into the solution decreases. The extent of adsorption increase with increase of surface area of the adsorbent. This is the general phenomena for all adsorption. We can say that as the surface area increases, adsorption increases. The extent of adsorption depend upon the concentration of solute in the solution. More is the concentration, more will be the adsorption. The extent of adsorption depends on the nature of the adsorbent and the adsorbate. So both, it is a kind of adsorption which depends upon both the type of or nature of adsorbent and adsorbate. The precise mechanism of adsorption from solution is not known, so we are not aware about the precise adsorption, but we can say that it is also following the Freundlich isotherm. So Freundlich equations approximately describes the behavior of the adsorption from the solution, with a difference that instead of pressure we use concentration term here into the equation. So for gases we have used the term pressure. For adsorption from solution we can use the term concentration. So now we can write the Freundlich equation for adsorption in solution. We will write x by m is equal to k into c to the power 1 upon n, where your c is the equilibrium concentration, or you can say the concentration at saturation, like saturation for adsorption. It means that concentration when adsorption is complete, when it is completed and the saturation has been obtained. On taking logarithms both the side, we can write log of x by m is equal to 1 by n log of c plus log of k. If we plot a graph of log of x by m versus log of c, same as we have seen into the case of the Freundlich isotherm, here also we have the log of x by m versus log of c. We can see that this y-axis intercept is your log of k, and if you take slope ab by bc, that is slope is equal to 1 upon n. This is how we really understand the now we have some questions to answer. The question is, how can we test the validity of Freundlich equation? Let us set it well so that we can see it well. Yes, now we can see it. Let me read the question once again. How can we test the validity of Freundlich equation experimentally for adsorption from solution phase? So now we'll have to validate this equation. So we'll have to do an experiment. The validity of Freundlich isotherm can be tested experimentally by taking solutions of different concentration of acetic acid. So we'll take the various concentration of acetic acid and we will have some 3 to 5 various concentration of acetic acid and various solution. Equal volumes of solutions equal volume of solutions of different concentration are added to equal amount of charcoal in a different flask. So we'll take equal volume of this various solution which are having the different concentration, and then in this solution we will add the equal amount of charcoal. The final concentration is determined in each flask after adsorption, concentration or saturation. That means we will find out the final concentration after in all flask. When the adsorption is complete, we will find out the concentration of the solute present into that particular solution. The difference in between initial and final concentration gives the value of x. So if we find out the, like, we know the initial concentration, then we find out the final concentration, and final concentration minus initial concentration will give us the value of x. Using the equation x by m is equal to kc to the power 1 upon n, or log of x by m is equal to 1 upon n log c log of plus log of k, we plot a graph of x by m versus log of c. If the graph is straight line, we can say that the equation x by m kc to the power 1 upon given by Leach is valid for the desorption into the solution phase. So we plot a graph after taking the log, and if the graph is a straight line, then we can say it is valid. Now we'll learn some of the applications of adsorption. First application of adsorption is production of high vacuum. For generation of vacuum we use a vacuum pump, but let us see how this adsorption is useful for us. If we use vacuum pump and evacuate air from a vessel, suppose there are some air present in the vessel even after evacuation by the vacuum pump, what we can do then, this air can be absorbed by the charcoal and we can have high vacuum in the vessel. So even after vacuum pump, if some air is present, that air can be absorbed by the charcoal, and then we will have the high vacuum. Gas mask is a device has activated charcoal or mixture of adsorbent which absorbs the poisonous gases. So when there is a poisonous gases available, one has to wear this gas mask, and then we can go inside. So these poisonous gases are absorbed by the charcoal or the mixture of other adsorbent, and we will not have the adverse effect of that particular poisonous gases. Gas mask is usually used for breathing in a coal mines. Coal mines have very poisonous gases, especially the carbon dioxide or carbon monoxide. I hope, my dear students, you are enjoying these studies. We'll see the other application into the next video. Thank you and happy learning.